here's this Mustang. This is got the old side pipes on her. Car's been here a few times. It's still on pump gas. It makes, I think the last time it was here, made 440, a little low 440s to the tire. It's just shy of 15 pounds. Like again, Procharged air-to-air intercooler deal. We've just changed the mass air sensor to it's a blow-through mass air, and it's a Pro M setup. But yeah, it's a built engine, different cam. I don't really know what cams are in it. It's got the factory intake manifold on it still. And yeah, it's a nice piece. Automatic car, obviously. We just put a different converter in it. It's got a PTC in it now. Curious to see what kind of power we can make. The last time it was here, we maxed the mass air sensor out, thus the change in mass air sensor. So we'll be able to turn it a little bit more RPM safely, and then also see how the converter acts. Yeah, I still got my stuff hanging out in here, but yeah, it's a nice car. It's got these aftermarket NRG Innovations leather seats in here. I've never seen these before. They're super comfy. And he said they were priced fairly well too. I haven't looked, but they're definitely nice. And yeah, that's it for this thing, man. Gonna dive into this and see what kind of power we can make once I get through the mass air curve. Up here, the left one's what we made this time, 450, 377 foot-pounds of torque, and it made 434, 387 foot-pounds of torque previously. Now the biggest difference there is converter and a little bit of RPM, but I wanted to show you these two graphs. Now these are over time rather than over RPM. A couple things to notice here. This step right there, that's where the converter couples, which is cool just to see that work over time. But the old pole, the dotted lines here, were started at 3,000 RPM in high gear, and the solid lines are this days, and they started at 3,500 RPM. So a little bit differently, a little bit later, but look at how much quicker it moved through the same RPM sweep as before. Now that is because the converter, as a good stall converter does, allows the car to get to peak power and stay there for longer, thus accelerating the car faster. And you're able to see that even here on the dyno. I feel like the over time graph there is a very good example why that's important. Now the converter is going to be, it is a little looser, so the car is definitely making more horsepower than before. Even if the numbers show they were relatively similar, it shows obviously it's making a bit more. But I'm thinking it's pretty significant over that. I haven't done the injector fuel flow data to give exact numbers on what it's making for flywheel numbers. Based on the mass air calibration, it's somewhere around 63 pounds of air a minute, which is usual rule of thumb is 630 at the flywheel. It's making about 15 pounds of boost. So you know, those numbers all make sense. Like I said, it's a built bottom end, nice cylinder head deal. But yeah, so curious to see what he thinks of it after he goes for a drive and makes a couple track hits, see what we can get for ET out of this thing. Converter is going to be a game changer compared to the old one, especially with a centrifugal car where they make very little boost at low RPMs. So getting the thing immediately up into the usable power curve is going to make the car significantly quicker than it was previously. But yeah, that's it for this thing. I'm going to roll it off here and get on to the next one.